Like we've explored before, when we have integer exponents, the rules apply the same if we have rational exponents. So it'd be good to go back and remember and review some of our rules or properties when multiplying or dealing or dividing with exponents. What do we do in those results? So let's look, for example, I have 6 to the 1/7. I'm going to multiply that by 6 to the 4/7. This follows the first model up there, where I have a base to an exponent times the same base to an exponent. This says I add the exponents, so this becomes x to the 1/7 plus 4/7. And then that reduces down to 6. Add the numerator, keep the denominator. That becomes 6 to the 5/7. With this example, it looks like I have a model that's similar to that second one there, where I have like bases, but they're being divided. So how do we deal with this? Well, I have 32 divided by 6, or 16. And with it like bases, the x's, I subtract the exponents. And then from there, just a process of simplifying it. 32 divided by 16 is a 2. The exponents, like bases to subtract, so let's rewrite 1/2 as 2/4 minus 3/4 gives me a -1/4. And then it's customary to simplify all your solutions when there's no negative exponent. So how do we rewrite that as a positive exponent or an expression with a positive exponent? 2 doesn't change. The x will go down to the bottom, and I'll rewrite it as a positive exponent. Have a base raised to an exponent, and then an entire product or sum or result, that's a better word, result, is raised to another exponent. Follows this third model that we have there. So that can become 8.3 to the 3/4 times 2/3. 8.3, that becomes 6/12, and I can reduce 6/12 down to 1/2. So 8.3 raised to the 1/2 is the result of this exponent raised to an exponent. Now this one, we have a lot of fun things going on here. So again, when we have a lot of fun, let's break it up into small groups of fun so everybody gets to play. Notice I have 2 bases raised to exponents, and those results are also raised to an exponent. So going slowly, I'm going to take this first base, distribute the 1/2 to it, just rewrite it like that. The second base is raised to a 1/3, and that 1/3 is raised to 1/2, which means I multiply the exponents. So I just distributed across 2 bases first. Next, let's multiply the exponents. So I have -2/5 times that. That gives me a -2/10 times the y to the 1/6. I have a negative, and I also have an exponent that can be reduced. What do you want to do first? Let's write it as x to the -1/5 times y to the 1/6. Negative exponents, I don't have that rule up here because that was previously, but we will remember that. That means I can rewrite its base as positive as long as I flip it to the denominator. So this becomes over x to the 1/5. The y is to a positive base, nothing changes with that. And that's left as y to the 1/6. So there's my final result. Again, I can't emphasize enough how important it is you just go step by step by step and understand what exactly is the base to the exponent that we're working with.